In this video, I will talk about the difference between position, displacement, distance, and distance traveled. So when we talk about position, we always want to find the position relative to a reference frame and with respect to another object in that reference frame. For example, if you're standing in the street and you're waiting for your friend to call you and she's trying to find you, you probably say, "Oh, I am standing 2 meters away from a coffee shop." So this is your coffee shop and you're here. And this is 2 meters. Or maybe you say, "Oh, I am standing inside of a bus stop." So this is the bus stop and you're standing right here. So you always specify your position with respect to something else. So if we assume that the reference frame is Earth and the coffee shop is at the origin of this reference frame, our position here, so this is the coordinate system, this is X, this is Y, and this is the coffee shop. And I am standing 2 meters away from the coffee shop. So my position, X, is equal to 2 meters. And if in a different coordinate system, I say no, I want to assume that the bus stop is in the origin, then I am standing in the bus stop and my position now is 0. But what about displacement? What is displacement? So let's say you stay in the bus stop for like half an hour, waiting for your friend to show up. But she calls you and says, "Oh, I'm sorry, I'll be a little late." So you decide to go to the coffee shop 2 meters away and get a coffee while you wait for your friend. In this case, you are changing your position from the bus stop to the coffee shop. So this is how displacement occurs. So displacement is defined as change in position of an object. So here's the equation for displacement. Del x is equal to xf minus x naught. So xf is your final position and x naught is your initial position. And del x is change in position or displacement. Okay, so in our example, let's say this is my coordinate system. And I want to assume that bus stop is at the origin of my coordinate system. And the coffee shop is here, 2 meters away from the bus stop. So you go from the bus stop to the coffee shop. So your displacement is xf minus x0. So xf, your final position, is now 2, and your initial position was 0. So your displacement is 2 meters. Now, let's say you are in the coffee shop, sitting at one of the tables, enjoying your coffee, and your friend calls you. And she says, "Oh, I'm here, I'm waiting for you at the bus stop." So you pick up your stuff and head back to the bus stop. So now, what is the displacement from the coffee shop to the bus stop? So this time, your initial position is the coffee shop. So your initial position is 2 meters. And your final position is the bus stop. So xf is 0. So now del x is 0 minus 2, or negative 2 meters. So notice that this time the displacement is a negative number. This is because this time you're moving in the negative x direction in our coordinate system. Okay, so but what is the difference between displacement and distance? So as we saw, displacement has a magnitude and also has a direction. However, distance is just the magnitude or size of displacement from one point to another. So displacement does not have a sign or a direction. So for example, in our example, the distance between the coffee shop and the bus stop is always 2 meters. It doesn't matter if you go from the bus stop to the coffee shop or from the coffee shop to the bus stop, the distance between the two locations is always 2 meters. So now let's talk about the difference between distance traveled and just the distance. So as I mentioned, distance is just another word to describe the magnitude of displacement. So the distance between two objects is always equal to the magnitude of displacement. It does not have a sign because it does not have a direction. However, the distance traveled can be larger than the distance or magnitude of displacement. So in our example, when we walk from the bus stop to the coffee shop, so when we walk from the bus stop to the coffee shop, here the distance is 2 meters. The displacement is 2 meters and the distance traveled is also 2 meters. But what happens when we travel back from the coffee shop to the bus stop? Now, as we saw, the displacement was negative 2 meters. The distance was 2 meters. But now the distance traveled is 2 meters plus 2 meters, or 4 meters. Okay, so now let's look at another example. Let's say you go back to the bus stop, you join your friend, and then you both head to the library. The library is 3 meters to the left of the bus stop. So what does it look like? So this is your coordinate system. This was the bus stop. This was the coffee shop, 2 meters to the right of the bus stop. And then this is your library, which is 3 meters on the left side of the bus stop. Okay, so now what is your displacement from the bus stop to the library? Your final position is a library. So your final position is negative 3 meters because library is in the negative side of the x-axis. Minus 0, which is your initial position, the bus stop, and that is equal to negative 3 meters. So this is your displacement. And what is the distance? As I said, distance is just the magnitude of displacement. So distance is 3 meters. But what about the total distance traveled? So if you want to find the total distance traveled from the first time that you were standing in the bus stop, so here's the bus stop, here's the coffee shop, here's the library, You went to the coffee shop, you came back to the bus stop, and then you walked to the library. So the total distance traveled is 2 plus 2 plus 3. So this is the distance traveled. Okay, I hope this video helped you to learn the difference between position, displacement, distance, and distance traveled.